Hi everybody. In this video, I'm going over example 3 from section 3.3. This is kind of a difficult example to understand on your own, so I really wanted to go over it thoroughly with you guys. So what we're going to look at is this kind of complicated looking set notation, and we're going to figure out how to solve what elements will be in it using 3 methods: visually, using pictures and shading the diagram; algorithmically, which is the sort of step-by-step process; and using the translation into words. The advantage of being able to use all 3 methods is you can start to think visually, especially, so that you can help your students with sort of visual logic as they learn. Not that they're going to be doing this, but so that you go back to the days before all you did for math was algebra and step-by-step stuff. So let's see if we can do this here. We're going to start with the set order of operations, which is very much like algebra, which is that you have to find anything inside parentheses first, starting with any knots. Then you go outside of parentheses and take care of any knots, and then you finally go outside of parentheses and take care of anything else. So let's look at how that plays out here. So we're going to find this here. This is A complement, or not A, intersect C, intersect B. And to do that, we're going to use the order of operations. So we're going to find A complement intersect C first, starting with A complement. That's the not inside those parentheses. So we got to start with A complement. Now, to do A complement, what we want to do is we want to shade A, and then shade anything that's not A. So in this picture, you can see that I've shaded A in orange. Everything that's not A is shaded in yellow. It includes all this stuff out here, and any part of B and any part of C that's not A. So this whole yellow area is our not A. That's our first step. So now we've done this first part inside parentheses. We've done the not A. That's the yellow coloring here. And now we want to do intersect C. So let's find C first and shade C. So if we shade C, this green part is where C is shaded. And now we want to find the intersection between those two things. Go back here to the text. The intersection between not A and C is everything that I colored in yellow, wherever that overlaps with what I've colored in green. So let's go back and look at these 2 pictures. So here's what I colored in yellow, and here's what I colored in green. Where do those 2 colorings overlap? In other words, what have I colored in both yellow and in light green for C? So look at the yellow picture for a second and imagine I colored all of this in light green, right? So this is the part I colored both in light green and in yellow. So that's this pink area here, right? That's the part that I colored both in light green and in yellow, this pink area. But we're not done yet. That's just the first part. Now, if you're thinking, oh, my brain hurts, bear with me. There's another way to do this that's not shading, but I really want you to try the shading and try to get good at both methods. So now we're going to do the whole thing that we just got intersected with B. So we shade B, and we try to see where it overlaps with this pink area that we just did. So we're thinking, where does this pink area overlap with shading all of B? So if I shade all of B in some color like blue, imagine it for a second, where would that overlap with this shading, just the pink part, Where would that overlap? The pink part overlapping with my shading all of this circle that is B. And I think you can probably see it now. It would just be colored twice here where you see the 21. So going back to our picture here, that means the answer to this whole complicated thing is just the number 21. For those of you who learn visually, that can work really well. For those of you who have a harder time visually, let's go over this algorithmically, which means like in algebra, using a set of rules or steps to do the problem. The first thing we're going to do, so algorithmic method has kind of got lots of listing. So the first thing we're going to do is we're still going to start inside here. Not A intersect C. We're going to start with not A. How do we start with not A in this method? Well, we look back at what A is equal to. So way back here, we see that A is equal to 4, 8, 12, 16, 20, 24, 28. And we list all the numbers that are not in A. Oh, and 84 is also in A. So what are all the numbers that are not in A? That's here. These are all the numbers in our list that are not multiples of 4. So it's a long list and it's a little bit of a pain to write it all out. But the nice thing about doing it this way is we can be very sure we've got our answer if we do it correctly. So we've got our list of not A, and now we want to find the intersection of that with C. So we list all the elements that are in C. Remember that C was multiples of 7. So 7, 21, 28, and 84. This is all part of the original problem that was posed. So where do those two lists overlap? So do they both have a 1, a 2, a 3? Nope. Oh, but look, they both have a 7 in them. So that overlap is in our intersection. They both have a 7, and they both have 21, and that's it. So that intersection is 7, 21, those two numbers, because both 7 and 21 are in not A and in C. And now finally, to get our final answer for not A intersect C intersect B, we're going to use this answer that we got up here, 7, 21, and we're going to use the B list. The B is multiples of 3, so this is the list of all the elements of B. And where does this 7, 21, this answer, overlap with B? And the answer is the only thing they have in common is 21. So that's our final answer. Notice that that final answer is the same as our final answer using the pictures. Finally, a couple key things to remember. One is that the words are going to really help you. If you look at the words, this is not A, that means not multiples of 4. C is multiples of 7. So numbers that are not multiples of 4, they are and are multiples of 7 and are multiples of 3. The only number that works for that is 21. 21 is a multiple of 7, it's a multiple of 3, and it's not a multiple of 4. So you can certainly use the words to try to figure out what your answer is. Key things to remember. This symbol, the intersection symbol, tells us we have to find the overlap. It means and. So it's where both things are true. If we're shading, if we're coloring, it's where we colored both of them. If we're using the lists, it's anything that's in common or the same to both lists. See you in the next video.